Hello everyone, welcome back. So today we are going to solve the next problem of the linked list series. Remove nth node from the end of the list. Okay, so let's read through the problem. So given the head of a linked list, remove the nth node from the end of the list and return its head. So it's clear from the problem statement. Let's consider this example one. So suppose we are given a linked list. This is our head and we are given n equals to 2. Okay. So we need to remove the nth node from the end of the list. So if n is equal to 2 means we need to remove the second last node from the end of the linked list. So second last node. So this is first last, this is second last. So we need to remove 4. So the new linked list would be 1, 2, 3, 5. Got it? So the question is easy. So now let's move to the like how will we approach to this problem. Okay. So now basically what we can do in this problem is we can use a two-pointer technique, right? Like how will like basically we'll use the two-pointer technique in order to find the nth node from the end in a single traversal, right? Like so what we can do is firstly we don't know the length of the linked list. So like if I have to remove the second last node, okay. So for removing the second last node, I need to know the length of the linked list, right? So I would traverse the list to calculate its length, right? And then I would subtract n from the length to determine the position of the node that needs to be removed from the start, right? So if I'll traverse this list, I would get the length as 5, right? Now I would subtract n. So I would subtract 2 from the length. So I would get 3, right? I would get 3. So 3 would be the position that needs to be removed from the start. Okay. Then I would traverse the list again to reach to that node and I will remove it. Make sense? So I would reach there, and once I reach there, I would do next dot next. So that node will be removed, right? So this could give us our answer, right? Just the problem with this approach would be that it would require two traversal of the list, right? First for calculating the length of the list, and second for calculating basically for traversing it again so that I could remove the nth node from the end, right? So this requires two traversal. So it would be less efficient, but it would be an efficient solution. But there could be one more efficient solution that could be done in a single pass. So let's see through that solution. Okay. So for that solution as well, I would use two pointers only. I would use a fast pointer, I would use a slow pointer. Okay. Now, the fast pointer would be uh, ahead by n steps. Okay, by n steps. So basically, I would start moving both the pointers simultaneously until the fast pointer reaches the end of the list. Okay. And the slow pointer will be like it will be just before the node that needs to be removed. Okay. So let's start with the code so that you would understand it better. Okay. So as I was talking about in the previous English problems as well, that firstly we need to create a dummy node. Okay. And later on we can remove turn that particular. Okay. So what I would do is I would take a dummy node. I would name it as dummy only. New this node. I could take it as 0. And also like we need to see the values as well. So the number of nodes we are given and the values are given. Okay. So the values are basically in order only. Like if there are 5 nodes, so values will be 1, 2, 3, 4, 5, like this. So I could take the dummy node as 0. Okay. Now I would connect it with the original list. So dummy node next would be head. So basically the linked list would look like this for now. 0, 1, 2, 3, 4, and 5. Okay. So so now I would initialize two pointers. Okay. Initialize two pointers. Okay. I would take it this down. Okay. So I would take a fast pointer and a slow pointer. Okay. Both will start from the dummy node. Okay. So the slow pointer would start from the dummy node and fast pointer would also start from the dummy node. All right. Now, as I was talking about, I would move the fast pointer n plus 1 steps ahead. Okay. Because when I'll move these much of steps ahead and then I'll start traversing both the pointers with same speed. Then my slow pointer would be just one step behind the node that needs to be removed. So that would be easy for me. Okay. So for that, what I'll do is I'll loop for I equals to 0. I'll so how will I okay, I'll write it down as well. Like I'll move the fast pointer in plus one steps ahead. Okay. So how can I do that? So I know the n. I know n. So I can traverse until n, right? I plus plus. Okay. So fast will be fast dot next. So now fast is already in plus one steps ahead. Okay. So both started from 0. Okay. 0, 1, 2. So n is 2. So fast moves here, here, here. So fast is at 3 right now. Okay. And slow is at 0. Okay. Now I'll move both the fast and both slow pointer until fast reaches the end. Okay. So move both pointers at same speed until fast reaches the end. Got it? So now, so I'll take a condition while fast not equals to null. So that will determine if fast is at end or not. Okay. So I'll move fast as well. So fast will be fast dot next and slow dot next. Right? Now, so both the pointers started moving. So fast would move to 4, slow would move to 1, right? Fast would move to 5, slow would move null, slow would move to 3. Okay, and once fast moved to null, like this would be null. Okay. One fast would go to null, will exit from this loop, and slow will be at 3. Okay. So now, so now you see, slow is just before the nodes that needs to be removed. Just before the nodes. So 4 needs to be removed and slow is here. So now you know what we can do. Like we can change the next of the slow to slow dot next dot next. So that would necessarily remove the node that needs to be removed. Got it? So you know, and we have done it in a single pass only. Like we have not done multiple passes, we have not done anything. It's just the single iteration, right? So now slow dot next will be slow dot next dot next. So the node is removed, right? And now since the node is removed, I can return the head. Okay. So w- what will be my head? So basically I would return dummy node dot next because it is attached to our head only, right? So I would return this. Okay. So I would quickly run this code. Okay. The base cases are running fine. I'll submit it. Yeah. So as you can see, it's running fine and it's running with a good time complexity. So it's an easy kind of problem only. Like once you get a hold of the logic, it's easy. Okay. So so now you got it. Okay. So basically what is happening is, so suppose in this example only, I'm moving fast pointer in plus one steps ahead. Basically three steps ahead. Okay. So after one step, fast would be here. After two step, fast would be here. After three step, fast would be here. Right? Now, this condition is done. Now I would move both the pointers at same speed. So here, fast would move to 4, slow would move to 1. Fast would move to 5, slow would move to 2. Fast would move to null, slow would move to 3. Got it? And once this condition is done, I'll get out of the loop and I'll do this so that the element is skipped. Right? So basically, the time complexity would be big of n only because we are traversing it up only for the one time. So, and the space complexity would be big of 1 because we are not using additional space. We are just using some pointers, so that doesn't count to the space complexity. So, so now I hope you got some things like you got like what is the power of two-pointer technique and how it is useful in solving the English problems, right? And the dummy node trick, right? You know that the dummy node trick is commonly used to handle the edge cases, right? And I highly suggest you to write it on pen paper so that you would visualize it how the linked list is working if you are not able to visualize it in your mind. But once you solve some problems of linked list, it's a very simple data structure. So that is fine. Okay. So I hope you like this video. Make sure to subscribe and I'll see you in the next video.